Hello everyone and welcome to this lecture on text classification. We saw in the previous case that how image classification can be seen as a traditional classification problem, or using deep learning approaches it can be modeled in fact in a different way where the whole image is directly supplied to the model. Same goes for the text classification as well. When we do text classification, and we will see with the help of a few examples what do we mean by text classification, but when we do it, there are two ways. Either we can consider our unstructured text and convert that into the well structured classification format, but using deep learning models like RNN. RNN stands for recurrent neural network. We can take the whole text and supply that to the model directly, and model will identify the pattern by itself. So let's start with this problem statement of text classification. So as a quick recap, in the last lecture we talked about what do we mean by image classification. We saw the traditional approach where pixels are arranged in a certain way, and then we saw convolutional neural network based deep learning approach where images can be supplied directly to the model. In today's lecture, we will focus on what do we mean by text classification, what is the traditional approach in this context, also a special category of neural networks called recurrent neural networks, which come under the umbrella of deep learning, and they are really suitable for text classification problems. So we will discuss them also briefly. We have seen this example many times now, but to do classification, traditionally what we do is we look for a well-structured data set with the XY pair, where X is the set of independent variables and Y represents the dependent variable. In text classification also, the generalized problem statement is same. That is, you have been given an input and the corresponding output Y, and you want to identify the relationship between X and Y. But in the case of text classification, the X matrix is not very well defined into X1, X2, X3 like this. But here we have a very unstructured text available. For example, let's consider this problem of a spam email. So given an email, we have to identify whether that email belongs to the spam category. It is an spam email like this, or it is not an spam email, it is a normal email. Now here we might have very big text like this. So it can be considered the X value, and the Y value is also given. But in the case of text classification, the problem then becomes how we will arrange this data in a way that it can be fed into the model, whether the traditional model or the deep learning based model. For that, we have to do some very specific preprocessing techniques which make sense only in the case of text classification. Make our data in the form so that it can be fed into the model, and then the model can do the final predictions. So we will look at all these pre-processing steps also in this lecture. There is another example for text classification which goes like, given some social media post, can the model identify whether that post shows the signs of suicide in a person? So as you can see, this is taken from some social media. This is a post, and yes, it shows the suicidal tendency. That's why the corresponding class is yes. In some cases, it is very straightforward, and the answer is no in this case. So we have to somehow look into these words, make sense of them, and finally do the prediction. So we will see both ways, the traditional way and the deep learning way of doing the same. Now, once again, as we have seen in the case of image classification also, we somehow take the image and convert that into the standard format, a structured format where any standard machine learning algorithm can be applied. The same is true for text classification also, but this time the input is a text. So we have to take this big text sometimes and convert that into a number of values which can be spread like the set of independent variables x1, x2, x3 and xn, so on, and the class is the same. We have to do that for the second text in the training set and in the testing set also. Once again, come up with the numerical values which represent this text and so on. Once we get this structured format, then we can apply the standard algorithms. Now let's see how this can be done. Traditionally, the approach of bag of words was quite famous, where we used to take some text related to problem like this and convert that into a corresponding numeric vector. So let's take an example. Let's say we have this email text. It has a certain text, attention please, this is to bring to your kind attention and so on. And let's say first how we can take this text and convert that into corresponding vector values. For that, often our text goes through many pre-processing steps. The one and very common pre-processing step is to convert the whole text into one case, either lowercase or uppercase, and converting into lowercase is more common, where every character is a lowercase character. Then often when we do this kind of classification, the value of exact numbers does not matter much. So if it is 10,000 or 1 lakh, it does not affect the decision making as such. So we either remove them in most of the cases or maybe convert them into just one common string, that is number. So wherever the number appears in your email, that will be replaced with number, or we can simply remove them. Another very common pre-processing step is called stemming. Stemming means that we remove the form from a word and we just reduce it to its basic form. When I say basic form, it means whether the word award appears in the email, awarded appears in the email, or awarding appears in the email, all of them will be converted into its basic form, that is award. Because the meaning of the word that might affect the classification is award, not its form, awarding or awarded. Similarly, we also remove what we call the non-words, which means if there are extra spaces in the email, if there is punctuation in the email, and so on. I mean, these kind of extra characters, if you will, they are removed. And we also remove the stop words. Stop words are those words which occur very commonly, frequently in the email or in any text, but does not add into the meaning of the sentence as much. For example, the word this or is or at, the prepositions and conjunctions, so they may not add much to the meaning of the sentence. That's why they are also removed. Sometimes we also do further processing. Let's say if we have some email address available in the text, then we just replace all the emails with some common string, let's say email. Because from where the email is coming, yes, for early decision making we can check that, but in the text, certain email address does not affect the classification task. So we replace them in email with some common string email and so on. It might contain some website address, some URL. So you might have HTTPS and some URL, and we simply just remove that and replace it with that string URL or HTTP address or something of that sort. So the idea is The things that does not affect the classification task as such, either we remove them or we convert them into a common word or form, so that we can focus more on the remaining words which are there in the text. So maybe if you take this email as our input, maybe it will be converted into a pre-processed text like this, where every word is a lowercase word. First of all, as you can see here, there are no extra characters here. If you can see here, there the email addresses have been replaced with some just email addr representing the email addresses. Some URL is replaced with HTTP address to represent it is simply a URL. The 100, the number has been removed. If you look at the other things here, for example, it has been removed because it does not add much into the meaning, so the stop words have been removed. Apart from that, if stemming is also done, so if there is this word expecting, then we have only expect here. So after pre-processing, we have only the words here that has made our text, and it is something in these words or group of words that make an email either spam email or a non-spam email. So we will consider only this combination of words now. So once the pre-processing is done and we have the words only in the text or email in this specific case, now the next part is how we can take this and convert that into numbers, into a vector form. For this is what we do. We take all the pre-processed email in the training set and we divide them into individual words or even characters. We call them tokens. Now tokens may not be always meaningful words, but usually they are the words in the text. So token means you have this group of email. After doing the pre-processing, we have taken whatever words are left here, we are calling them tokens. Now all the tokens of the whole training set, they are combined together. Let's say if there are 1000 emails in the training set, then we'll take all the words after pre-processing which are available in these 1000 emails, and we will combine all of them together, and out of them we will fetch the set of unique words. So maybe the word let's say John, it might appear 10 times after combining all the emails, but we will keep only John only once in this new set, and this set is called vocabulary. So before doing the text classification in bag of words approach or the traditional approach, we first come up with a vocabulary, and vocabulary is the set of all the unique words that have appeared in the training set after carrying out the pre-processing step. And this vocabulary serves as a foundation for further classification. Maybe when we do this, we come up with this kind of vocabulary, which has a total of 2000 unique words. Maybe the word zip appears as the last. It has the index 2000. So in the vocabulary, as you can imagine, zip, if we arrange them alphabetically, zip will come last. So it is the 2000 at the 2000 index. The word anyone might appear at index 86. Able might appear at 3, and so on for the other words. So for this specific case, our vocabulary has 2000 unique words, and the words are also matched with the corresponding index. Now, once this vocabulary is made out of the whole training data set, the next step is to take our spam email and compare that with the vocabulary. So how do we compare that? You see that for all these 20,000 entries, we create a table where we have 20,000 independent variables like this. And we take the first word and we see whether this word appears in the vocabulary, and if it appears, at what place it appears. So anyone appears at index number 86. So there is somewhere x86 also, and corresponding to this email we make its entry as 1, which means when we compare the email with the vocabulary, the 86th term of the vocabulary actually appears in this email, right? Let's say we also check able here, which appears at x3 in this new table, right? We check whether our email contains the word able. Since it does not contain the word able here, we will put a 0 there, representing that the third word of the vocabulary, which is able, does not appear in this email. Okay, let's also try zip. The same happens with zip also. Zip does not appear in this email, so the corresponding index is going to be 0. So what we do is we take each word of the email, we compare that with the vocabulary. If it is available in the vocabulary, we mark the corresponding entry in the table as 1. Otherwise, we mark the entry as 0. 0 represents the absence, 1 represents the presence. And since we already know that this email might be, let's say it's already given to us, it is an spam email, so the corresponding y value would be 1, where 1 represents it is an spam email. So what we are trying to see here is that what are the different words of the vocabulary which are also there in the spam email, and what is the corresponding class, that is the y value. And the same has been shown here also, which is the mapping of the given email with the vocabulary. Mind you, there are 2000 independent variables here. Each will have either the value 1 or it will have the value 0, representing the word is there or no. And finally, we have its the corresponding class, which is y, 1 representing a spam, 0 representing not a spam. So once we do that, then each email can be represented as a row in this new table. It is now in the structured form. 1 here represents it is an spam email. For the second email, we do the same. Turns out it is not an spam email, and so on. So we arrange our training data like this. And we do that for all the emails. Now, once we have this form, numeric form, well-structured form, then any standard machine learning approach, neural networks or others, even logistic regression, since it is a binary classification problem, can be applied on this data set. And this overall process is called bag of words approach. However, in the era of deep learning, this has changed now. And deep learning primarily rely on the concept of word embedding in order to achieve the text classification solution. Also, apart from word embedding, models are used that can process sequential data, and text is seen as a sequential data because the word that will come later might be attached with the word that has occurred previously in the text. So it is sequential in nature. Words come in order. For that, we commonly used recurrent neural networks for text classification tasks. We will discuss recurrent neural network briefly, but you should know that for sequential data, whether it is text, once again, sequential means the new word might be dependent, or the new input, you should say, might be dependent on the previous input. Such a data is called sequential data. So whether it is uh, text, or it is speech, or it is audio, all of them are sequential data. And for these problems, usually recurrent neural networks and their advanced versions are the preferred choice. So let's see what do we mean by recurrent neural networks and how they can be used to solve text classification problem. So a recurrent neural network is a type of artificial neural network designed to recognize patterns in sequences of data such as text, speech, etc. And unlike traditional neural networks, which process inputs independently, these RNNs have loops within them, allowing information to be carried across neurons while processing the sequences. Now, this characteristic of having the memory makes RNNs particularly useful for sequential tasks, because they can maintain information in their memory for the time being from the previous input and then supply this information to the next input or the current input. Now, these deep learning algorithms are commonly used for tasks such as language translation, speech recognition, image captioning, where you have been given an image and you have to generate a corresponding text which describes the image, and have been incorporated in many popular applications actually, like Siri, voice search, and Google Translate. Like feed forward and convolutional neural networks, recurrent neural networks also utilize training data to learn. They are distinguished by their memory, as they take information from the prior inputs to influence the current input and the output. While traditional deep neural networks assume that inputs and outputs are independent of each other, the outputs of the recurrent neural networks depend on the prior elements within the sequence. So let's see how how they look like, and what is how they do the processing, where they store the input and then forward that to the next output. Let's see that. Often you will find that RNNs, they are represented like this. So the first one is a rolled form, where, so this is the processing neuron main. It takes the input from here, it goes here, and there is a loop here. So it does the processing multiple times. It stores the current processing and then waits for the next processing, supply the previous processing to it, and it goes on. And finally, the output is made. If we take the same set of sequences and put that in the unrolled form, you will find that first node, it takes the first input, does some processing, gives the output, but at the same time it sends the information to the next processing unit also, so that when the next input comes here, then it can fetch the information from the previous input also, and combining both the information, it can carry out the output and also forwards the information to the next processing unit. So if we have a sequence like red ball, so red will go there, it will be processed, ball will go there, but when ball is being processed, it will take the red information from the previous input and will attach that with the information that is associated with the word ball. So this is how recurrent neural networks they do the processing. They just keep on combining information from the previous steps and keep them forwarding to the newer steps. There are many variations. There are many types of recurrent neural networks. They could be one-to-one, where you have one input and you are expecting only one output. Let's say for example an image, and you want to check whether that image is dog or no. So it is a one to one because you have one input and one output. It could be one to many, where the input is one but the generated output has many sequences within it. So for example music generation, so you maybe pass a word like pop, and depending upon this one input many notes of the music are generated. So you have one input but multiple outputs. We can also have many to one. So when we do classification, let's say the spam detection that we are currently discussing, here we have a larger text with lots of words here. So we have many inputs in this specific case, but the output is going to be either yes or no. So there is only one output node, maybe one representing yes, zero representing no. And sometimes we also have many to many recurrent neural networks commonly used in machine translation, where we want to take text in one language and want to convert that into another language. So for example, we are supplying a input text in English and we want answer in Hindi, let's say. In that case, we have multiple words going as an input and we are expecting multiple words in Hindi, of course, that should be outputted by this recurrent neural network. So there are many variations of recurrent neural networks available. Now let's talk about when we apply recurrent neural network, that what is the common process that takes place. Often when we do text classification using RNN, these steps are very common. It first requires some pre-processing, not similar to what the traditional approach like back of words does, but is still some pre-processing is required. So the first thing that you can see here is called tokenization. Tokenization is the similar what we have seen earlier. So we take this text and we convert that into individual words, and these words are called tokens. Once again, tokens are not exactly words all the time, but when you divide text on the basis of its spaces in between, the individual component is called a token. So this is step number one. Then we do the vectorization. Now vectorization is not similar to what we have done when we were creating the vocabulary, and if the word present it is 1, if it is not present that it is 0. This process is called embedding actually, where the tokens are converted into numerical values. Now one common approach is to use word embeddings. It's very common, which provide a dense representation of words in a high dimensional vector space. Word embeddings are a type of word representation that allows words to be represented as vectors of numbers in a continuous vector space. So they are not discrete like 1 or 0 or 2. They can be 1.5, 6.2 and something like this. Unlike the traditional representations of words or as discrete symbols, word embeddings encode words in a way that captures the semantic meaning and relationships among words. It provides benefits like dimensionality reduction because we are not comparing with the whole vocabulary. So vocabulary is usually really big in back of words. Here we have in word embedding we use much smaller or dense representations. It provides other benefits like arithmetic operations are possible because it is a continuous number, it is not discrete. It gives you benefit of performance improvement and many more. So just to give you one example of that, if in word embedding, if we use the word, let's say king and queen, they are more close to one another than other combinations. The reason being that king represents some level of royalty and a queen also represents the same. So they are more close in the multi-dimensional space than other pairs. So this is what word embedding does. Obviously it has lots of mathematics and reasoning behind that, so we are not discussing the same. But this is what word embedding does. It does not treat each word independently, but tries to also consider which words are similar to one another, and they must have same representation in the high dimensional space. After vectorization process, we do the padding, because RNNs requires inputs of the same length, but different text might not within that same training set also. Let's say in the case of a spam detection, some emails could be much longer in comparison to the other emails. So what padding does is they make them of same length. Usually we insert zeros in the beginning or end to make all the emails or all the text in the general way to be of equal length. Once this pre-processing is done, then we try to first design a RNN model like we did in the case of CNN model. Typically, RNN models contain three layers, at least three layers: one input layer, some recurrent layer, so you can have multiple recurrent layers also, and one output layer. So input layer, simply it accepts the pre-processed text that we have discussed in the form of vectors, but this time not the word. They have the word embedding representations, the dense representations in the form of vectors. So input layers takes data from the pre-processing step. Then comes the recurrent layer. Now these layers use the sequence of vectors from the input layer, and each unit in these layers possesses one vector at a time in sequence, maintaining a hidden state that represents information it has seen so far. And once this information is identified, it is passed to the next unit within the layer. So there are many types of recurrent layers, but long short-term memory or LSTM in the short form, or bidirectional LSTM, or GRU are another type of recurrent neural networks, layers called gated recurrent units, GRU. Gated recurrent units, they are advanced RNN architectures commonly used to avoid some problems that occur in traditional recurrent architectures, like vanishing gradient problem, and provides certain other benefits also. Like in the initial types of recurrent layers, there is a problem called long-term dependency problem. That is, if the previous state that is influencing the current prediction is not in the recent past, then RNN model may not be able to accurately predict the current state. So if the words are closer to one another, then traditionally RNN can remember that. But as the gap between the words become more, there is long-term dependency. In those cases, these layers were not very performing well in those cases, and that's why we have more advanced recurrent layers like GRU is there, LSTM is there, BiLSTM is there. So we often use these layers. Finally, we have the output layer. Now this layer uses the final state of the recurrent layers to classify the text into one of the categories, yes or no, or if it is multi-class classification, then in some specific category. For binary classification, a single neuron obviously is there with sigmoidal activation function, but for multi-class classification problem, multiple neurons are there in the output, and softmax activation function is used while we are doing the text classification, where each unit in the output layer represents a specific class. So overall, text classification has many applications, and here also we have the traditional approach. Most commonly used one is bag-off approach, which first develops a vocabulary, tries to form the given text into a structured form, and then apply the traditional machine learning methods like artificial neural network and others, We can actually use CNNs also for text classification, but they do not perform better, at least in comparison to RNN models. In especially in the sequential tasks, they have limitations. So RNN based deep learning approach are much more efficient for problems like text classification, and that's why they are more common for the same. And RNN, especially based on gated recurrent unit GRU and by LSTM, they have become more common in this specific task of text classification. So this is all about this lecture. In the next lecture, we will see how we can solve the text classification problem with the help of traditional approach once again, and how we can solve the same with RNN based deep learning models also, and then we can compare both the approaches. So this is all about today's lecture. Thank you.